This video is homework problems from page 162, 77 to 92. I don't know that I'll get to all the problems, but I'll work a good representation of the problem, so hopefully it will help you get the idea if you get stuck. So let's start with number 77. In 77 we have f of x equal to e to the negative x times the ln of x. Now the fact that I said times tells me that we're looking at the product rule here. So when we do the product rule, we'll take the first function, which is e to the negative x, times the derivative of the second function. Remember, the derivative of ln of x is 1 over x, plus the second function, ln of x, times the derivative of first function. That's going to be e to the power times the derivative of the power. And the derivative of that power is negative 1. In terms of cleaning that up, I will get I can take this e to the negative x and move it to the denominator and make it 1 over x e to the x. And in the second expression, that'll be minus. I can move the e to the negative x to the denominator and have ln of x over e to the x. And in terms of cleaning that up, I could get a common denominator, but I'm not asking you to do that at this point. Problem number 78 is e cubed times the ln of x. E cubed times the ln of x. Now remember, e cubed is simply a number. E cubed is a number. So basically it is a coefficient. So it's not the product rule, since that is a coefficient. When I find the derivative, e cubed is going to be my coefficient that comes along. All I'm really going to focus on is finding the derivative of the ln of x, which as we know is 1 over x. So I get e to the x over x, which will be my final answer for number 78. 79. Looks like I may need more room for 79, so I'm going to go to a new page. Number 79 is y equal to e to the x times sine x plus cosine x. Now this is one of those problems that you're going to look at and evaluate and decide, do I want to distribute the e to the x, or do I want to leave it as it currently is written? Alright, so think ahead. If I distribute the e to the x, what that will create is two product rule problems versus what I currently have as one product rule problem. So in this case, I am not going to distribute the e to the x. I'm just going to do the product rule from the beginning. So I'll have the first function, e to the x, times the derivative of the second. The derivative of sine is cosine, and the derivative of cosine is negative sine x. So all of that was first derivative second plus the second sine x cosine, plus cosine x times the derivative of the first, and the derivative of e to the x is simply e to the x. Now what I can do here, I can factor an e to the x. I have one term and two terms. Each term has an e to the x, so I can factor out an e to the x, and if I do, that'll leave me with, from the first term, cosine x minus sine x plus sine x plus cosine x. You'll notice that I have a negative sine x and a positive sine x that will cancel out. So I have y prime equal to 2 cosine x e to the x. And it doesn't matter if you write that as 2 e to the x cosine x, but that would be your final answer. And that's a pretty easy simplification to take care of. Number 80. Number 80 is y equal to ln of e to the x. And if you play your cards right, you won't have to do u prime over u, because remember, the base of an ln is e. So they're inverse functions and they undo each other. So really, this expression is equal to x. So this is really saying y is equal to x, and of course, the derivative of x is just 1. 81. G of x is equal to ln of x squared. And we know that the derivative of ln of u is u prime over u. So the derivative of this function would be u prime. X squared is my u. The derivative of x squared is 2x over u prime over u. This x will divide with one of these, and I end up with 2 over x. 82. ln of 2x squared plus 3, so h of x is equal to ln of 2x squared plus 3. Again, we have ln of u. The derivative of ln of u is u prime over u. 2x cubed plus 3 is my u. The derivative of that would be 6x squared over u is 2x cubed plus 3, and that will not simplify or reduce. Do not try to divide anything in the numerator and denominator in this problem. 83. Y is equal to ln of x raised to the 4th power. Now notice that this is an inside and an outside function. The inside function is ln of x. The outside function is the power of 4. So we're going to apply the chain rule. All right, I'm going to bring the 4 down, so I have 4 ln of x to the 3rd power. All of that is the derivative, whoops, that's a stray mark. All of that is the derivative of the outside, multiplied by the derivative of the inside. The inside is ln of x, and the derivative of ln of x is 1 over x, so I can clean that up and simply make it 4 ln of x cubed over x. And nothing simplifies, nothing reduces, nothing divides. 84. In number 84, we have y equal x ln of x. And that is a product. Be careful, it's easy to overlook that because it looks like it's all kind of together, but it is a product. This is my first and this is my second function. So here we go, the product rule. First times the derivative of the second plus the second times the derivative of the first. Cleaning that up gives me this x divides out with this x, and I have 1, don't forget the 1, plus ln of x as my final answer. Okay, the next problem, which one was that? That was 84. 85. In number 85, I have y equal to ln of x times, I'm going to go ahead and change that to x squared minus 1 to the 1/2 power, even though it had square root of, because that'll just save me a step. All right, we know there are two things that we can do here. What I would do to make this easier on myself is I would use log properties. What I'm doing is I'm taking the ln of a product. So from Algebra 2 and Pre-Cal, we can rewrite this to be the ln of x plus. Also, another log property is the fact that this power of 1/2 can come in front of the ln, so I have 1/2 ln of x squared minus 1. Now, if I did not use the log property, then my alternate route, I'm going to draw a line here, my alternate route would be to view this as the ln of a quantity, and we would have u prime over u. Now, the u prime would end up being a product rule. I'm not going to do that whole problem out. So you'd have to do all the product rule with what's on the inside there, and then it would be divided by, which is a lot more work and a lot more possibility for careless error. All right, so over here, remember, all I did is I rewrote using algebra. Now I'm going to find the derivative. The derivative of ln of x is 1 over x, and the 1/2 is a coefficient out front. The derivative of ln of u is u prime, 2x, over u, x squared minus 1. Cleaning that up, this 2 divides out with this 2, and I have y prime is equal to 1 over x plus 1 over x squared minus 1. And again, for now, that's okay. You don't have to get a common denominator at this point. All right? Moving on to problem number, let me get rid of this right here. Problem number 86 is y equal ln of the, again, I'm going to go ahead and rewrite this as a power, x squared minus 9 to the 1/2 power. I have two choices. I can do u prime over u from the get-go, or I can use algebra, oops, not y prime, I can use algebra and rewrite this expression by bringing the power using a log property, like that. So when I find the derivative, the 1/2 is a coefficient. The derivative of u prime in this case would be 2x over u, which is x squared minus 9. 2's divide out, and I get x over x squared minus 9. So using those log properties really makes your life much easier. All right, number 87. F of x is equal to ln of, this is kind of a big one, well, it's actually not that bad, x over x squared plus 1. Now remember your log properties from Algebra 2. This is a quotient, so I'm going to do an algebra rewrite of ln of x minus ln of x squared plus 1. So that keeps me from having to do the quotient rule. The derivative of ln of x is 1 over x. The derivative of ln of u is u prime over u, and that will do it, even though you could get a common denominator. And I'm sure if you check your answers in the solutions manual or in the back of the book, they will in fact get a common denominator. All right, f of x is equal to, in number 88, same kind of problem, ln of 2x over x plus 3. I'm not going to work this problem out, but it would be done exactly like the last problem. I would use log properties, and then from there I would find my derivative. Number 89 is g of t equal to ln of t over t squared. Now in this case I cannot use a log property to rewrite that because I'm not taking the ln of the entire fraction. I'm only have the ln in the numerator. So we're definitely going to have to go with the quotient rule here. So, now I could move the t squared to the numerator and make it t to the negative 2 and use the product rule. I'm going to go ahead and do the quotient rule. So we would have down d up minus up d down over down down. Cleaning that up a little bit would be, so I have a t squared and a t. This t will take out one of those, and I have t minus 2t ln of t over t to the 4th. Now I'm noticing that every term has a t. Here's a t, here's a t, and here's a t to the 4th. Now the t with the ln does not get reduced. If I divide every term by t, I will get 1 minus 2 ln of t over t cubed. And I think you can handle that simple reducing. If you did the product rule, your answer might look a little different, but it should be the same, just re-expressed. Number 90. Almost done here. Number 90, h of t is equal to ln of t over t. Same thing, I'm not going to do this problem because basically it's the same problem with a different expression. Again, use the quotient rule. Number 91, y equal to ln of, this is a big one, going to rewrite it as a power, x plus 1 over x minus 1 to the 1/2 power. Again, this is where my log properties are going to make this problem into a very simple problem. If I don't use the log properties, it's going to be a lot of algebra and a lot more work. So my log property will allow me to move the exponent to the front, 1/2 of the ln of x plus 1 minus ln of x minus 1. Now notice I used the log property with a power, and I used the log property with the quotient. So I get y equal to, the 1/2 is a coefficient that stays out front. We did an example like this in your notes. U prime over u, the derivative of x plus 1 is 1 over u, minus u prime, again, is 1 over x minus 1. I don't have to get a common denominator, but I could if I wanted to. Let's just for fun go ahead and get a common denominator, which would be the product of x plus 1 times x minus 1, except I didn't write that correctly. Sorry about that. So if I multiply x plus 1 times x minus 1, I get x